two examples that look very similar but are very different in cause. The causation is different. Would we all agree both of these individuals have unilateral, widespread, but only unilateral, and that's the key, water density? So we have homogeneous opacification of a hemithorax. That's still unilateral water. So it still fits under Cat P. Is it consolidation? Is it atelectasis? Is it tumor? Is it pleural? Is it external chest wall? Now, what can we eliminate easily? External chest wall. Why? Well, look at all the silhouettes. It can't be on the external chest wall and silhouette anything except the external chest wall. So E's gone, easy. Now, if it was consolidation, it would have to be every segment and every lobe on that side, wouldn't it? Mm-hmm. Which is possible, but unlikely. I don't think consolidation is a good choice. Could atelectasis give us that? Yeah. Could tumor? Not likely. It'd be an enormous tumor if it did. It would have to be an entire hemithorax tumor. Those kind of things just don't happen. But atelectasis can do it, and pleural can do it. Both of those can cause homogeneous opacification. And the key with these two different examples is where the mediastinum went, where the anatomy went. So in the top one, which way did the anatomy go?
To the right.
Away from the density.
It went away from the density, didn't it? It went away. If you follow the trachea down, trachea goes like this, see it? Mm-hmm. And look where the heart border is. We've never said it's okay for the heart border to be halfway into the right lung field. The right heart border is just barely right of the midline, isn't it? Not halfway. So in this one, it looks like things are being pushed away, doesn't it? Mm-hmm. Well, if things are being pushed away, something's getting bigger. And it's pushing out of the way, right? How about the bottom one? We have homogeneous opacification here, but look where the trachea is. Trachea is over here, see it?
Not at all.
Hmm?
Where do you see the trachea?
It's right here.
Okay, I can see the top a little bit.
No, it's this radiolucency right here. Right under my finger.
Yeah, okay.
That's the trachea. So which way did it go this time?
Toward the density.
It went toward the density. And where's the heart border? Well, there's the left heart border. The heart didn't move as much, but the trachea moved a lot. But the whole mediastinum is still going toward. So what's happening? Something's getting smaller. Something's shrinking, it's pulling everything toward it. So here we've got expansion, and here we've got contraction. Shrinking, getting smaller, getting bigger. And where the mediastinum went relative to the density. And that's the whole point of these two. This has got to be atelectasis, doesn't it? And it's got to be atelectasis, likely of what cause? I mean, is it resorption, passive, adhesive, or cicatrix?
Absorption.
Okay, well, we know what happens if the obstruction is in a lobar bronchus. Then we get a lobe collapses. And we get fissure displacement. We can see the fissures. Can you see any fissures? No. Well, what would happen if the patient had a pneumothorax and the lung collapsed? The mediastinum doesn't move toward the density. It doesn't move with passive unless it's from fibrothorax. So this one is resorption atelectasis because that's the one typically where stuff moves toward, is resorption. Remember, those are most of the indirect signs are things moving toward the increase in density, aren't they? That's what most of the indirect, except compensatory emphysema. Anything that can move is going toward the increase in density. Well, up here, this patient has atelectasis, but you can't see it. This patient has a very large pleural effusion. And so the pleural effusion is causing what kind of atelectasis?
Compressing.
It's causing compressive or passive atelectasis. Exactly. which is squeezing in on the lung, what density is the lung becomes as it collapses? Water.
Winner.
Surrounded by a big pleural effusion, water. Water, water, so where's the lung? Can't see it. Silhouetted. It's silhouetted. And here, yeah, the lung's collapsed, but it's the whole entire lung. It's not a lobe, it's the whole entire lung. So where's the obstruction? Where's the obstruction?
In the main bronchus.
Main stem bronchus, exactly. And if it's in the main stem bronchus, all the lobes together collapse. That's why we can't see any fissures, because they're collapsing on both sides of the fissures, so you can't see them. So this is a right main stem bronchus obstruction. This is a huge pleural effusion, probably infectious. This is probably a big mess of edema and exudate in there, collapse in the lung.
How would that look different than hydrothorax?
That is hydrothorax.
Oh, okay.
That's just kind of the generic name for it.
Okay.
It just means a liquid in the pleural space. Yeah. This is the same thing as tension pneumothorax to the lung. It's just a liquid instead of air doing it. But it's the same problem. It's just with pneumothorax, you see the lung really clearly. But with this, you can't because it's silhouette. Okay?